Hello everyone, I am Shupatra Pancha, Assistant Professor, Department of Computer Science and Engineering, PhD SVP Dr. PG Hakati College of Engineering and Technology, Vijaypur. In the last class, I have discussed about a secret sharing key schemes. So in that, we have discussed three different scenarios. So how to find out how to determine the secret key? Yes, among two users, among three users, and finally among m out of n users, like that we have discussed. So the importance of secret sharing between the authorized users. So now in today's class we will be discussing about random numbers in cryptography. So how random numbers are useful in cryptography, useful in transmission of encrypted data between the authorized users. So here I think you might have understood something about while transferring some amount from bank to one bank to another bank. So it asks about OTP. So every time what it generates the random number OTP, different OTP. So in such cases, the random number algorithm will be uh, created, and with the help of random number algorithm, every time the OTP will be generated that is unique. So that is one such example. So in that way there are several examples wherein you can use the random number. Random number generation is very important aspect in cryptography. So why actually we will be using random numbers? Random numbers used to generate keys, the very first point. So random numbers are used for generation of keys here. And in keys, there are several types of keys. As I discussed already in the previous classes, different types of keys. Okay, one such keys are symmetric keys. Symmetric keys in the sense, symmetric keys are those wherein only a single shared secret key used between the authorized shared symmetric key is used between the two authorized users. That is what symmetric is. Then one more is RSA. So there's a clear example they have given prime numbers. RSA is an example, is an algorithm to generate the keys. But RSA determines RSA is a part of public key encryption. So it's a RSA is a key which are related to the public key encryption. So in such case also random numbers are very useful. Third one is Diffie-Hellman. Diffie-Hellman, the topic itself is called as Diffie-Hellman key exchange algorithm. So this Diffie-Hellman is an algorithm generated by the two authors, namely Diffie and Hellmans. So that's what you can call it as a Diffie-Hellman key exchange algorithm. So whatever the keys are exchanged between the authorized users, those are random. Random numbers used for nonces. So nonces, I think just now I said something about OTP. So it's a one-time generation. So nonsense will also be called as a one-time generation of unique values. Sometimes a sequence is okay. So sequence will also be considered for generation of such number. But sometimes nonsense must be random. That's what I said. Random numbers also used in simulations, statistics, etc. So there are wide varieties of random numbers, wide varieties of uses of random numbers. So in such apps need statistically random numbers. So in that what we are going to concentrate about cryptographic random numbers. Cryptographic random numbers must be statistically random and unpredictable every time what the particular cryptographic algorithm is going to generate. That should be very unique and random, which cannot be predicted. That is what we can call it as unpredictable. Suppose server generates symmetric keys. So first in the first for the first transmission, it generates one such key, second random number, third random key, like that. Suppose server generates a symmetric keys. So in that we will be discussing some notifications here, some notations. So Alice comes with the secret key called as KA. Then Bob is given a secret key called as KB. Charlie is given a secret key called as KC. Dave, one more name, called as a secret key, given as a secret key called as KD. So Alice, Bob, and Charlie don't like Dave. So in that, Alice, Bob, and Charlie working together must not be able to determine KD. Then what all three users can determine? Alice can determine Alice can determine either KB or KC. Bob can determine either K or KC. Then Charlie can determine either K or KB. So all three are working together, but all three must not be able to determine KDB because Alice, Bob, and Charlie don't like Dave. So these are some notations. So next, one more very important concept in this particular random number is that is online version of Texas Hold'em poker. I think many of you are aware of such games here. So it's a card game. So it's a card game, that's what you can call community cards in center of the table, players hand. So what I can tell you in this is, I'll tell you very briefly. So in such games, we need to shuffle the cards every time, and that shuffling of cards should be the maximum number. There is a possibilities of, say for example here there are 52 cards, assume it. So then the randomness of such cards should be 52 factorial, which is greater than 2 raised to 225 possible of sepals. So it is not actually. So with algorithm, that is what I can call it as the online version of. So manually, if we play, then we can randomize the cards in our own way. That is manual. That's different. But in the online version of Texas Hold'em poker, online version of that card games, what we need to go for is the better. We need to use the better way in the random numbers. Random numbers used. So what we have to use here is we have to use the concept of random numbers for shuffling of such cards. Used to shuffle the deck. Program did not produce a random shuffle. A serious problem. So if we go for normally, it cannot produce a particular or perfect random shuffle. A serious problem. Actually, it's a serious problem because in online it should produce high randomness. So in this card shuffle, what we have is there are 52 factorial, which is greater than 2 raised to 225 possible shuffles. The poker program used random 32-bit integer to determine the shuffle. If it is 32-bit integer, then there are only 2 raised to 32 distinct distinct shuffles could occur. The code used Pascal, that is pseudo random number generator PRNG, randomize. There is a function so which will generate all 2 raised to 32 possibilities of card shuffling. Seed value for PRNG was a function of number of milliseconds since midnight. So it calculates the randomization in the form of a time that is in terms of milliseconds. So less than 2 raised to 27 milliseconds in a day. So less than 2 raised to 27 possible. So if we consider exact whole day, then also there are only 2 raised to 27 possible shuffles. So it is less than 2 raised to 27 possible shuffles. So that's what we'll go for. We can also call this as a seed based on milliseconds since midnight. PRNG reseeded with eShuffle. So by synchronizing clock with server, number of shuffles that need to be tested less than 2 raised to 18. So we need to go for synchronize that particular server here. Would then test all 2 raised to 18 in real time. Test each possible shuffle against up cards. So here in this, attacker knows every card after the first of 5 rounds of betting. So here, what we need to do is, so while giving the algorithm, we need to be very careful that we should produce the maximum randomization. So that's what attacker knows. So in such possibilities, in this attacker knows every card after the first of 5 rounds of betting. So poker example, that's what I said. Poker program is an extreme example, but common PRNGs are predictable. Only a question of how many outputs must be ob- observed before determining the sequence. Crypto random sequences not predictable. For example, key stream from RC4 cipher. This is an example. But seed here in the sense, don't be confused that seed. Seed here is a key. Key selection is still an issue. How to generate initial random values, that is without keys and in some cases seed values. So after all discussing this particular card game, what I can hold'em poker game, so we need to go little bit about the basics of random. So these are just examples of random numbers. So in the next class we'll be discussing something about the basics of random number. Thank you.